Hello, my name is Nicholas, and this is the first in a new series of videos covering my research into the fields of swarm robotics and swarm intelligence. So, firstly, what is swarm intelligence? The basic idea of swarm intelligence is to use lots of smaller, simple components that all work together to accomplish a task larger or more complex than any of the components could individually accomplish. These components, often called agents, are usually given some degree of artificial intelligence and some greater or lesser ability to communicate with each other. Since starting, I've found swarm robotics to be basically the application of swarm intelligence principles to physical hardware devices. I've also found useful research in the fields of artificial intelligence, particularly distributed artificial intelligence, as well as multi-agent systems. These all seem to be fields that are related. So, with the background out of the way, my project is to design and develop a swarm intelligence simulation. This simulation will be a hypothetical planet exploration where a team of robots are landed on the planet and must explore and collect scientific data with minimal human input. This may potentially also include simulation of hardware limitations such as power and battery life and retrieval of damaged robots for repair. Specifically, I plan to build several types of robots. Scout robots, which have a very large sensor radius and which will initially spread out to survey the area and then form a communications network to pass information around. Movement robots, which will be able to move around the environment and push or pick things up and move them. Task robots, which represent robots with specific capabilities, such as being able to break down rocks or drill core samples or measure temperature or any task that requires specific hardware, as well as a central hub which will represent the shuttle that has landed on the planet and which will then form the hub of the operation. With the inclusion of battery life and robot power limitations, there may also be a solar robot representing a mobile solar array which can be moved around on the surface, collect energy, and which is then returned to the hub to then share that energy and spread it out across robots that need to be recharged. So, this is the simulation I'm developing and where it currently stands. I have thus far implemented two different types of robots. Scout robots, you can see one up here highlighted in yellow, and movement robots, which you can see just here with the red arrow on it indicating which way it is facing. I will let this simulation play and you will see the functionality that I've developed so far. We can see the scout robots obviously spreading right out to get the best coverage of the local area, and we can see the movement robots just hanging around in the center. Already we've got one scout robot that's lost contact with the network and is trying to find it again. So what we can see is these blue circles represent the sensor range or the view range of the individual scouts, and this sort of shows you how much of the world the scout network actually has vision on and understanding of. We can also see which scout robots are connected to which other scout robots, which sort of gives us a visual understanding of how the network is laid out and where the communications can happen. We can also see the movement bot view range in red circles. Obviously the movement robots are not designed to be highly situationally aware, they're designed just to move around and manipulate things, so they only need a very small understanding of the environment around them. We can also see which scout robots can talk to which movement robots. The movement robots which are inside a scout's vision range can be communicated with. Currently, we have one major functionality implemented, which is the ability to see a click upon one of these scout robots, creating a task which will then summon movement robots from the network. What happens is the click creates a task that this scout robot now owns. It will then transmit that task to all of the scout robots it can see, and each of those robots will then in turn transmit that request throughout the network following these communication lines until that request can be fulfilled by pulling resources from the network. So if I click on this scout robot up here, we can see these robots have received that request and are now moving upwards through the network to that position. Once they arrive at that position, that request is now flagged as fulfilled or done. it will stick around for a short amount of time and then it will be deleted to clear up the network. So if we click over here, we can see robots gathering that way, and we can click here and here and just watch as these robots move along the communication lines to fulfill those tasks. If I reset the simulation here, we can see that every time it is started, the robots will move around randomly, spreading out to form a new network. We can see that sometimes the communication lines can be quite indirect, and if, for example, we wanted to get robots from this position up here all the way around to this position, rather than being able to take the shortest route across this gap, they would have to follow the network's understanding of the environment, because there's no way for them to actually know that this robot is just across this way. I also have the ability to create new scout robots with a key press, which means I can create new robots and sort of show you how the network moves around to accommodate for the new robots, and where they need to go in terms of the spreading out. The requests within the network are currently sorted using a hop counter, so that the further away the request is from where it was created. So if I create a request down here, every time it gets passed to a new robot, its hop count is increased by 1, which means that if we have branches in our network, say the request goes up here to this scout robot and also up here to this scout robot, when these two scout robots attempt to communicate that request to this robot, if one of those requests has a lower hop count, that is, the request is closer to the source of the information, the robot will choose the closer request and will in fact use any closer requests to overwrite their own understanding of the information that they have, meaning that if robots closer to the source of the request have new information saying that that request has been fulfilled, that information will then spread outwards through the network, so that even if this guy has all the robots he needs, people who haven't quite managed to understand that won't be sending him resources still. So currently, the only request that the network understands is that of a mouse click upon a scout robot to summon movement robots. These manual click requests summon 5 movement robots. Sometimes you get the exact right amount, as we have here. Other times you may only get 4 robots or 3 robots. It really depends on how the network spreads that information and what happens to that information while it's in transit. The plan is, though, that in future what will happen is these scout robots will in fact generate their own requests depending on what they can perceive in the environment. That is, certain things within the environment will trigger the scout robot to say something needs to be done here. I'll make a request to summon resources towards that task. The idea is also that other robots, say the task robots that will be moving around within the network, will also be able to say, I need helpers, or I need someone who can do this particular task, communicate that up to the nearest scout robot, and then have that scout robot pass that request so that the resources can be pulled in. So this is the current state of the simulation. From now on I'll be working on improving how the requests are spread and sorted within the network, possibly working on creating new types of robots and creating the ability for them to recognize their own tasks. That update coming shortly. Thank you guys for watching. This simulation is being developed using C# and XNA. If there are any technical questions or things that I haven't answered, please feel free to ask those questions in the comments below. Also, if there's any research that you guys have come across, whether it be different approaches or design paradigms or particular examples that you think might be interesting, leave those as well. That would be really appreciated. So that's all for now. If you enjoyed this video, check out my channel. There's lots of other development projects that I'm working on, and please subscribe to stay tuned for further updates on this project as they come. I hope you enjoyed it. I'll see you guys next time.